the HPC team, which I work for, wanted someone to take over iRODS, and they chose me for some reason. So they have declared to the entire 130 servers, 300 petabytes data, so 30 petabytes data, that I am the new iRODS administrator. So that's where the journey started. And if you have watched the movie Lion King, there is a famous song, Hakuna Matata. I'm not going to sing it now, but yeah, that's that's what I thought when they were giving me last year. So how do I manage all this? Yeah, it's Hakuna Matata. Um, yeah, there's no problem. Yeah, that's where the problem started because we were yeah. So what happens is we have a lot of sequencing machines in Sanger. So we have NovoSeq, we have Illumina, we have all the latest gen sequencing going on. So they will sequence the genetic data and they will produce something called as BAM or CRAM files. It is just ATCG in random order something. So that's the BAM CRAM files. Then this is fed to the iRODS resource tree. And then from the iRODS resource tree, we replicate it on the on-site data center and the off-site data center. So this is very important for us because the genetic data is very important and we don't want to lose it. So we want to make sure we have 2 copies. So that's where we use the iRODS resource tree for the replication. And yeah, so this is our iRODS resource tree. So we have a data object, we have a root, then we replicate it. We have 2 branches. One is the on-site, one is the off-site. Then on-site, we have a lot of resource servers. Off-site also, we have resource servers, and we end up with 2 replicas. This is the ideal world, and world is never ideal. So what happens is we had a lot of issues with the replication. The first thing was we had single replicas. Single replicas are when we have on one, so we just get one replica, but we don't get the second one. So we are at risk of losing data because we just have one. And if we lose it, we are losing the sequencing data. So we had around 34,243 single replicas in our zone, which is quite a huge number. And then even when we had 2 replicas, the 2 replicas were not identical in nature. So their checksum was different. So that means we don't know which one is the right one. So the data is corrupt. So that's another issue. So we had 1352 dirty replicas. So we also had more than 2 replicas, which is again, we are wasting our resources. So we had 3 replicas where 2 replicas are on one side and 1 replica on the side. So we had, this is a huge number. So yeah. So, but still this is not a problem because the iRODS team has this command, iadmin modrisk root rebalance, which will fix all this. That's like, again, Hakuna Matata, but it didn't happen like that because as I told, we are using 427 and 427 didn't have logical locking. So we needed logical locking. It was in iRODS 429, but we are in 427, but that is also not a problem because if we upgrade to 429, we are done. But that's where the problem was because we couldn't upgrade to 429, and I will share why later. So we are blocked there and we are at the risk of losing data. So I started developing an in-house Python solution to deal with this. So the first thing was fixing single replicas. So as you can see, the first thing we have, first I got a list of the single replica data objects. Then we have to identify which branch it is. It is an on-site or off-site. If we get it on on-site, we need to then figure out, okay, we need to replicate this on off-site. In the off-site, we have a lot of resources. So first we need to select the resource on which we want to replicate this. We'll remove the resource out of the tree, replicate it. Then we have we have 2 replicas. So that's the happy world we had. We faced a lot of issues here because we were using 427 and we had 130 plus resource servers. So there are a lot of complications there, but we successfully completed the single replicas. The second thing was dealing with dirty replicas. The important thing was here to understand which replica was dirty, which replica was good. So one thing which we do while ingesting the data, we add a checksum to the metadata. So if the checksum on the disk didn't match with the checksum on the metadata, then we know it's a dirty replica. But we wanted to be sure because we are going to delete one replica and replicate the other one. So if the replica which we are going to delete is the right one, then we are again losing data. So we had 3 checks here. The first thing was we are going to check the metadata where the checksum is there. Then we are going to check the status in the catalog. then we are going to check the checksum on disk. So only after getting these three right, we are going to trim the replica. So it is again, yeah, you find the right replica, then you delete the replica, then you move the resource out of the tree, replicate it again, then you have two replicas. So this is dirty replicas. So triple replicas, before we want to start triple replicas, we wanted to make sure if all the replicas which we have are not dirty or good, because it's important we don't trim the right one. So this is simple when compared to both of them, because we just identified which had the additional replica and we trimmed it. So this is the end of the replication thing. Then coming back to why we were stuck in 4.7 for more than a year. So we had a lot of plugins. One of the plugins which we're using is storage steering plugin. So our storage steering plugin was working on 4.7, but when we tested it on 4.11, it was not. So again, we had a lot of calls with the iRODS team. They helped us a lot. And then, so just to tell you what does it do for us. So we have two replicas initially, but we wanted to save space. So we already have 30 petabytes of data. So after 5 years of time, we want to move the old data to an archive zone. So there is European Genome Archive where we will store the data. So we just want to make sure we add the metadata. So these two replicas will go to a different tree. This is the resource tree which we initially had. This is the null repl root. This is where we don't do any replication. We just store one copy. So we make sure that the storage steering plugin will add metadata to the data object, and then it will automatically replicate this on the different tree, trim those two replicas, and get us this one. So this was very important to us because we're going to save data, and this was not working in 4.11 in our installation. So essentially we fixed all the bugs, but we haven't upgraded yet. So we are still due on that. And the next thing is, yeah, challenging with the current architecture. So currently we have a very complicated architecture where the user will request issue an iget command, goes to the database, which has a billion rows, then goes to the servers, then download the database, then stage it to Lustre file system, and then use it. So these three are the issues where we are overwhelming the database. Then we have a lot of resources to manage. If a disk fails in one of the servers, then we have to look at white field and we have to mark it down. Nobody can use it, then bring it back. Then we also have an intermediate file system, which we have to use. So we are planning to move to a simple world where users can directly read the data by mounting the file system, iRODS file system. The abstraction should happen within, so we need not manage each individual server there. And the replication will also be managed by the file system. So that's where we are heading towards in the future. And yeah, that's it from my side. Hakuna Matata.
All right. Any questions? We got one up here at the top.
Hello, and thanks for the presentation. And just one question there, like doing all these checksum computations, and yeah, we know that they can require a lot of time. What are the consistency requirements from, let's say, the application itself, in the sense that, okay, those operations are going to take time. So how much time are you as technical team and also the users to wait until these checks and these consistencies achieved?
So it didn't take much time. So for one data object, it took around maybe 1 minute kind of thing. So all the checks and there. So what we did is the users were not impacted on this. Only the ingestion pipelines were stopped. So this is like the data users will be using the existing data. So it didn't impact the users as such, but the single replicas took a lot of time. It took 2 days to run because there were 34,000 objects. The dirty replicas took around 5 hours to complete it. Yeah.
Okay, thanks.
Hello. I also heard that you said you were removing the resource and then replicating and putting it back into the tree. I was wondering why you were doing that.
So we can't replicate it when it attached to the tree. That's the reason we had to remove it and then replicate and bring it back. Yeah.
Was it the data object that you were replicating or the whole resource?
So we want to replicate the data object on the resource. So the resource, when it is attached to the tree, we were not able, we're getting error while replicating it. So is that the design thing? Yeah, it's a design thing with the iRODS. So we have to remove it from the tree, then replicate it and put it back into the tree.
I have a question about users' life cycle. How do we manage users to use LDAP or just rely on the iRODS users database?
How many users we have here?
No, about the users' life cycle. How do you manage the users there? Your iRODS.
Right. So everyone, so first of all, we use PAM authentication. So we have a federated zone. So we have 4 zones. And first the user will authenticate to one zone. From there, it will be redirected to the zone which they want to use. So initially we will create an iRODS account for them. Once we create the iRODS account for them with the permissions, so we deal the permissions separately. So the data, the ACLs are dealt in a different way. So users can read everything, but cannot write on everything. So the ACLs are defined in such a way you can view what data is there, but you can't download it unless you have the permissions to do it. And then if user leaves the institute, we'll block their account, iRODS account. It's because it's linked to the PAM authentication. Once that is blocked, this is also blocked.
Yeah, right. And you do it all in the PAM module, or you use some external service for that?
So this is dealt with Active Directory thing. This is linked to the Active Directory.
Yeah, but the user creation and blocking, this is done by the PAM module, right? The PAM module relies information from the Active Directory.
Yeah, this is using the PAM module.
Right.
Yeah.
Oh, okay, thanks.
Do you have any idea what caused the badly replicated objects in the first place?
Yeah, so we tried to debug this and we never understood why it happened. So there could be a lot of reasons. Yeah, Terrell made we spoke to them multiple times on this.
So our most educated guess is that this is all before logical locking. In fact, logical locking was introduced and thought about and brained and written because of what we saw. Sanger is writing, they were writing concurrently from multiple sources into the same data object. And of course, only one's going to win and the other one's not going to know about it. And now you've got a corrupted replica. So because it was because of the parallelism and the concurrency, which is now not possible anymore because of the logical locking. So they're still in 427. They're still susceptible to this. A corrupted replica could still occur in their current system, right? Once they upgrade, they should never see them anymore, at least for that
Hopefully,
reason.
yes.
Yeah. But we don't know. Stay tuned for next year. Maybe there will be a new.
All right, maybe just one more question. I think there was one here.
I was wondering what kind of client you use to push all this data to iRODS?
What kind of
Client? Are you using just a terminal and you push it? Or
so
you
there's a pipelines team which have written their own client, which is called as Baton, and then that's what they use. So it's in the GitHub. So yeah, I think it uses this C++ API, iRODS API. Yeah.
And yes, one question is how do you observe the users, the data they have in these iRODS instances? So how a user can discover the data that's inside?
Right. So users will use metadata search. So we will the pipelines team will add metadata to the actual metadata, and then they use metadata search to get there. So use the command line tool because they know the metadata. They'll search for the data and discover it. So that's.
All right, we're going to take one last question from, I think Justin had some. Okay.
This is from Mustafa. Do you have any statistics about which client operations result in locked objects? The PRC, iCommands, Globus, et cetera?
So we have used PRC2. So the logical, you're asking logical locking or?
Yeah, I assume that's, yeah, I think it sounds like what it's about.
So what was the question?
4 to 9 is where logical locking was introduced.
Right. So yeah, I'm not sure.
You had bad replicas, but not locked objects. That was not a concept.
Right.
Not sure.
Yeah, I don't know if that was about a previous comment or so.
Okay. All right. Thank you, sir.